All right, number 1 says give 2 other names to line AE. So what's something else we could call line AE? Yep.
AE with the line over it?
Well, I would argue that that's the same name.
Why?
Because that's the same name. It's a different way of writing the same name, but that is the same name. What else could you use?
Line
AC works, so you could write line AC or AC with the arrow over it. What else, John? Line EC. Okay. And the order of those letters doesn't matter. It could be CA, it could be CE, but that would be a different way to name the same thing. And if there was a lowercase or italicized letter next to it, that would be another way to name that line. 2, give another name for plane S, and this could be a couple of different things, but give me one example. How else do we name a plane other than that solid letter? You could do DBF, yes. So DBF, it has to be 3 non-collinear points. That one works. Anything else? Yep. DEF works. So any combination with F, because F is non-collinear, it would have worked. So DEF, BEF, DBF, any of those would have worked. So you could also do EBF. Okay. Any of those would work because they are non-collinear. It has to be non-collinear. You cannot use DEB because DEB are all collinear. Which answers number 3. Name 3 collinear points. D, E, and B are collinear. What else is collinear? A, E, and C. Good. 4, name the intersection of line AC and plane S. Where do they meet? At E, which you could write the word point E, or you could literally just put E because that means the same thing. Questions? So again, we talked about this last week, but how you choose to organize your notability is up to you. If you're wanting to go like a chapter, like this would be all under chapter 1. If you wanted to organize it by like type of, like we're going to do notes, we're going to do warm-ups, we're going to do homework, okay? Those would all be separate things, maybe test reviews. You get to choose how you do that. If you are using Canvas to annotate on these, I would then say make sure you export them to Notability. You don't want to be digging through Canvas to try to find warm-ups that are completed. You want them in Notability. It'd just be easier to review this stuff. These are good things to review before quizzes and tests, right? So to go back and review, obviously we're going to give you some reviews, but you always want to go back to like the warm-ups are kind of a quick condensed way to review the content. Homework is the other good way to review. All right, 1, 2 is called measuring and constructing segments. So notice it's segments. Obviously, it's not lines because we cannot measure a line, okay? It does not end. So the things that we're going to do today will apply to line segments. Using a number line. So there's 2 different parts to a number line, the coordinate and the name of the coordinate. So the point obviously is the letter. The coordinate is the numeric value on that number line. Hopefully we know some properties of a number line, like it goes from left to right. The smaller numbers are on the left, the bigger numbers are on the right. Okay, that should always happen. And then the distance between 2 points can be either found by doing the larger one minus the smaller. So you could do larger minus smaller. Or order doesn't matter if you put it in absolute value. You could just find the difference between the 2 points by subtracting one from the other and putting absolute value around it. Difference should never be negative. Okay, the distance between 2 points cannot be negative. Okay, it is also known as the length. So distance is also known as the length. So if it says what's the distance between A and D, that is the same as saying what is the length of AD. It wants the numeric length. Okay, a postulate is something you're going to hear a lot this year, okay? A lot of times they have a name to them. But a postulate is just defined as a statement accepted without proof. A postulate a lot of times is like a definition or a formula or something that is easily determined from information that you already know. So the ruler postulate is this first one, okay, which basically just says that the points on a line can be matched 1-to-1 with real numbers. So any point on a line can be matched with a numeric value like you just saw on the number line. And once a coordinate system has been chosen in this way, the distance between the 2 points equals the absolute value of the difference of their coordinates, which is what we just did, okay? This is called the ruler postulate. You'll probably see this mentioned like one other time over the course of the next quarter. It's not very popular. You don't use it very often. You use it, but it doesn't usually ask you to explain why you're using it, but it is called the ruler postulate. So when you talk about length or you talk about the distance between 2 points, it comes from the ruler postulate. A construction is a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. So go back to like before your time, and almost like most of the chapters in some way we would have some sort of construction in which you're drawing out using a ruler, using a compass, using a protractor, that kind of stuff. Now most of it we do digitally, so there's not a whole lot of constructing. You won't be ever tested on constructing, like having to construct an angle bisector or anything like that is not something that you'll be tested on. There are times in which we might actually do it, but you won't have to do it for like a quiz or a test. Congruent. Congruent objects are objects that have the same size and shape. So there are two parts to it, the size and the shape, okay? Which means that a triangle can only be congruent to a triangle. A segment can only be congruent to a segment. Okay, a hexagon can only be congruent to a hexagon. You cannot compare a triangle to a square. Even if it has the same area or anything like that, that's not what makes it congruent. Congruent is same size and same shape. So congruent line segments are segments with the same length. So if it says that the AB and CD are congruent, that means that they have the same length. Postulate 2, and this one is a popular one, so you're going to use this a lot. It's called the segment addition postulate. And it says if B is between A and C, then AB plus BC equals AD. So just to get a visual on that, if I have a line segment, and I have A, and I have C. That's my big segment. That's the whole segment. And B is anywhere on this. It doesn't say it's in the middle. It just says it's between. It can be over here. It could be really close to C. It doesn't mean it's in the middle. It just says it's in between. Then this postulate says if I take and add AB and BC together, I get AC. So a lot of times postulates are like, oh, that's just like common sense, right? If I took a segment, I broke it into two parts and added it back together, it should be the whole. That's what it is, okay? But in geometry, you're going to have to explain why things happen the way they happen. So if you were to say, like, let's say that this is 3 and this is 9, and I ask you to find the length of AC, you would tell me it's what? 12. And if it said, how do you know that? You know it because of the segment addition postulate. So there's a lot of justifying the steps that you're doing in geometry, okay? So if it says, what is it and how do you know that? Segment addition postulate. And we can shorten it. We do SAP a lot, segment addition postulate, okay? Just know those are the same things. All right, so example 1 says plot these 4 points in a coordinate plane and then determine whether JK and LM are congruent. So we're going to plot them. J is negative 3, 4, so I'm moving left 3 and up 4. And I'm going to label it J. K is 2, 4, to the right 2, up 4, and I'm going to label it K. L is 1, 3, and M is 1, negative 2. And it wants to know if JK and LM are congruent. What's congruent mean? Same size and shape. So we have the shape part down, right? How do I know it's the same size? Literally count them, okay? 1, 2, 3, 4, 5. This has a length of 5. 1, 2, 3, 4, 5. This has a length of 5. Are these congruent? Yes. If they were not vertical or horizontal, that's where your distance formula comes into play. So you would have to use the distance formula to find the lengths, okay, if they are not vertical or horizontal. We're going to get to distance formula a little bit later, but if it was standardized tests, you'd have to use the distance formula to find it. Questions? All right. Always, sometimes, never. These tend to, not so much yet, but these tend to really get people, especially in geometry, because it's more of a test of the true or false. It is like always, sometimes, never means you have to know it so well that it is either always, it has to be this way, it can be this way, or it can never be this way. So number 1 says the length of a segment is blank negative. We just said this, right? What is it? Never. It can never be negative. 2 says if point S is between R and V, then S blank lies on RV. Always. Okay, if it's between R and V, it has to lie on RV. 3 says a coordinate can blank be paired with a point on a number line. Go back to that ruler postulate. What was the wording on the ruler postulate? Always. All right, now comes the algebra. J is between I and K. Ij is 2x, Jk is 4x minus 6, and Ik is 30. I would strongly recommend giving yourself a visual on these. So if J is in between I and K, it's anywhere in here, I and K. Ij is 2x. Jk is 4x minus 6. And Ik, which is the whole thing, is 30. And then it says find the value of x. How do I do that?
Subtract.
Subtract what?
9x and 2x. I mean 9x minus 6 and 2x.
Subtract them from what?
30.
You're warm. We're going to add them. Good. So I want to take those two parts and I want to add them together and set them equal to the whole, right? We're finding x. Yep. So 2x plus 4x minus 6 equals 30. We are basically using algebra with the segment addition postulate, right? That says take those two parts, add them back together, and you get the whole. So I'm going to combine my like terms. 6x minus 6 equals 30. Add the 6. 6x equals 36. Divide both sides by 6. And what is x? X is 6. So that's the first part. Then it says find ij. How do I do that? Good. Plug it back in here. So 2 times 6 would be 12. Then it says find jk. There's actually two ways to do this. What's one? Plug it back into jk so I can plug 6 in here. What's the other way? Subtract it from 30. Good. We know the whole. We know one part is 12. We could just subtract it from 30. 30 minus 12. Either way, and if you need to do it both ways, you could. So this would be 24 minus 6, which is 18. This is also 18. Questions? Yeah.
6 back into 9x minus 6.
It's 4x. I know it looks like a 9, but it's 4x. Yeah, my handwriting looks like a 9, but it's 4. Any other questions? Okay.